The VERDE system provides a fourth-generation situation awareness for communities that need to not only see what is going on, but also to know how it affects their operation, forecast how threats evolve, and now to select in a Watson-like approach from simulations, scenarios, and exercise-indicated course of action options. This fourth-generation capability is particularly suited for isolated or under-resourced communities, mission planners, and rural leaders. The key to this capability is to have data sets and feeds to see what is going on to interface and initialize our models. Let us describe first the data sets and feeds available with a VERDE subscription. The power grid topology for the U.S. is constantly being updated using document searching and correlation techniques under the Almeria Analytics license of Oak Ridge Raptor technology. These topologies are provided as a base map for most natural disaster response, and the topologies are not limited to continental U.S. systems, but the topology has global coverage organized by each combatant command. The metadata extends to all energy infrastructure assets, such as the details shown here for a natural gas compressor station, as well as demonstrating its interdependencies. For the energy sector, these static data sets are supplemented by feeds from the participating utilities to provide the up-down status of the greater than 65 kilovolt transmission lines. These lines also include their connection and interdependencies with the major natural gas transmission pipelines and future routes under construction. Interdependency models then can map, in this case a county-by-county map, of the current state of customer outages, which can be extended into the future through fragility databases coupled with forecasted weather conditions. These forecasts are not limited to the energy sector, but extend to all 18 critical infrastructure sectors, including major transportation routes like this study prepared for Portland, Maine. In addition to the transportation routes, the population that will be impacted by these threats are updated using the Oak Ridge Landscan population database of where people are located with 30 arcsecond granularity. The analyst can select any section of the impact area, and the population in the impacted selected area is automatically summed and presented to the analyst. These impacted individuals can then be assigned to service areas, for example, to the cell towers that provide communication services as deployed personnel or evacuees move through the area, or in the case of a military commander, the primary civilian network for non-critical networks or dedicated facilities for critical connectivity. Datasets of the probability of asset failure versus wind, temperature, or precipitation threat can be coupled with weather feeds and 96-hour forecasts to provide estimates of where lifeline utilities will be interrupted and for how long. The weather feeds are obtained from the National Weather Service MEDAR network that provide, among other weather data, the wind speed, gusts, precipitation rate, as well as trend data. By coupling the precipitation rate with the USGS instantaneous stream gauges, threats from flooding potential can be assessed. During major typhoons, cyclones, or flooding events, the stream gauges are granular enough to construct flood zones with details that initiate projections for how long transportation routes will be disrupted and inundation of critical nodes. The Live Weather Radar provides development of weather systems and integrates the National Weather Service weather advisories and warnings. The infrared signatures from the MODIS satellite constellation provides location of wildfires, their velocity, and critical assets in their path. In addition, flaring from petrochemical facilities can detect upsets in critical facilities. Based on these data feeds, models, and forecasts, scenario libraries are built, and both sensor data and natural language reports are used with Watson-like search algorithms to present options. For example, during the Hurricane Iniki exercise on Oahu, in order to respond to a cyber intrusion at the same time as the storm recovery activities, scenarios for power conditions, repair resource availability, and mission priorities can be presented as maps of outages and restoration times. As a result of the cyber intrusion, change mission and asset priorities and cascading impacts and options can be presented down to the granularity of individual circuits whose status can inform the cyber restoration efforts and the deployment of defensive tools. These capabilities provide a suite of data, models, and analyses for the commander, for rule decision makers, for emergency planners, for strategic planners, all driven by the VERDE decision engine.